So today we're going to look at an example using the Poisson distribution. So I grabbed this example from your book, and it's a good example because it's going to review a few different methods that we're going to have to use. So it says a mail order company receives on average 5 orders per 500 solicitations. We know we're going to use the Poisson distribution because we're given on average and we're given an interval. So our lambda is equal to 5, and our interval that we're looking at is equal to 500 solicitations. So any probability that I ask you about has to be related or referencing 500 solicitations. If I change that interval, if I change that number 500 solicitations, I'm going to have to change my lambda value. So let's go ahead and get started. So part A says find the probability of receiving exactly 7 orders when 500 solicitations are mailed. We still have that interval of 500, so we know we can use our lambda that we have of 5. All right, so to answer this question, we need to start by defining our x, our random variable. So we're going to let x equal the number of orders received, because part A asks us to find the probability that we're going to get exactly 7 orders. So the probability that x is equal to 7. All right, so we know we're going to use the Poisson distribution. And since we actually have, I'm going to make this a different color, since we have x equals and we have an equal sign there, then we know that we're going to use the Poisson PDF. Maybe I can make that a different color, so I'll use PDF. And the reason why we're using a PDF is because we have an equal sign. We want to find an exact value. All right, so our calculator is going to ask us for a couple things. It's going to ask us for our lambda. Oops. So let's see, our lambda is equal to 5, and then our x value is equal to 7. So when we put that into our calculator, I end up getting 0.1044, and then the next number will be a 5 if I round to 4 decimal places. Now, if you forgot how to put that into your calculator, just a quick reminder where you find that Poisson distribution is you're going to go to, let's see, Stat, List, Editor, and then you're going to go to F5, and then you go down that F5 menu until you get to the Poisson distribution. All right, so the first one is pretty straightforward. You have an equal sign, so you're going to use Poisson PDF. Your interval is 500 solicitations, and the problem gave us our lambda for 500 solicitations. So let's go and look at part B. Part B says, find the probability of more than 7 orders when 500 solicitations are made. So I'm going to go ahead and change colors here. Maybe. All right, so let's see. So part B is 500 solicitations still, and our lambda is set for 500 solicitations. So we know we can use the same lambda, but part B asks for more than 7 orders. So for part B, what we're trying to find the probability of is the probability that x is strictly greater than 7. Now we can't have 7, it has to be more than 7. So really we're looking for the numbers 8, 9, 10, and so forth, all the way up as far as we can go, all the way to infinity. We have a couple different options for this. We know we want to use our Poisson distribution because it's programmed into our calculator. We know that if we look right here, we actually have an inequality, so I'll change the color of that. And if we have an inequality, we want to use the CDF. So what I want to use is the Poisson CDF, and I want to use the CDF because I have an inequality. I want to accumulate areas. I want to accumulate probabilities. I want to accumulate the probability of 8, 9, 10, 11, 12, all the way up to infinity. And our calculator doesn't know how to do that, but we can kind of trick it. We know that the further we go, if we go all the way up to x equals 1,000 or x equals 10,000, we're going to get a pretty good estimate of what this probability will be. So we can do this problem actually two different ways. So here's method one. We can use the Poisson CDF. Oops. And if we use the Poisson CDF, then we know our lambda is still equal to 5. And then we're going to have a lower value, which would be 8, because 8 is the first value I can actually have. I can't have 7 because it's strictly greater than, so 8 is the smallest value I can have. And then my upper value, I have to give my calculator the upper value. I'm going to pick a very large number, like 10,000, and that's going to help me estimate this probability. So if I plugged this into my calculator, I would get 0.1333, or if I rounded, 34. Oops, there we go. So that's method one. Method one tells me I'm actually going to estimate this upper value of some large number like 10,000. Now, method two is similar to what your book shows and what we did in class. I don't care what method you use. So method two would say, okay, if what I want to find is the probability that x is greater than 7, then I can use the complement rule, 1 minus the probability of the opposite. Well, if I want to find the probability that x is greater than 7, the numbers I'm looking at, the smallest number is 8, and then 9, and then 10, and then I keep counting. So the opposite of this would be the numbers I haven't included. The smallest number here is 8. So that means the opposite probability must be all the numbers less than or equal to 7 because they're not included here. Right? 7 would not be in this list, and a number smaller than 7 would not be in this list. So this is the opposite probability. And then I would be able to say, okay, that's 1 minus. Then I could use the Poisson CDF, and I would be able to say, okay, the Poisson CDF, my lambda is equal to 5. My lower value is equal to 0. My upper, I guess I'll write it below, my upper value would be equal to 7. So that would give me 1 minus 0.86668. And then if I round to 4 decimal places, that gives me 0.1334. So I get the same answer either way. They're just two different methods, right? The first one is using estimating the upper value with a large number, and the second one is using the definition of the complement. So both methods are just fine. All right, last one. If they send out 100 advertisements, find the probability of receiving at least 2 orders. So here I'm only looking at 100 solicitations. So my lambda is going to be different. I'm going to have to change my lambda value. Lambda has always been for 500. So now I need to figure out what does lambda have to be so I have an interval of 100. Well, lambda was 5 when my interval was 500. So for me, if I divide this by 5, I get 1. If I divide my interval by 5, I get 100. So lambda would be 1 when my interval is 100. I can check that. If I multiply this lambda by 5, I get 5. And if I multiply my interval by 5, I get 500. So I know that I made it proportionally smaller. And now I'm looking at the probability that x is at least 2. So if I go down and I look at C, let's see, C would be the probability that x is at least 2. So greater than or equal to 2. And again, I can use either one of the methods that I used in part B, right? I could either use estimating the upper value with a large number or using my complement rule. Either one is fine. So I'm going to go ahead and say, well, this is equal to the Poisson. And I'm going to use the CDF because I know I want to accumulate some areas or accumulate some probabilities. and my calculator is going to ask me for my lambda, and we found our new lambda, so lambda is equal to 1. And then I'm going to say my lower value is equal to 2, and my upper value is equal to 10,000. Again, I'm just choosing an arbitrarily large number to estimate my probability. We can do that because as the upper value gets larger and larger, it gets closer and closer to the true value of the probability. And since we're just taking it out 4 decimal places, 10,000 seems to be plenty. All right, so that means that probability would be about 0.2642. All right, so the probability that we have at least 2 orders would be about 26%. All right, thank you.